One day we're gonna live in Paris, I promise.
Y prime equals AY for the matrix A equals -2, 0, 0, -2. And we're given the initial condition y of 0 equals 3, -2. So the way we can go about this is find the eigenvalues. Since we have a diagonal matrix, we know the eigenvalues are -2 and 2. So we have one real eigenvalue of algebraic multiplicity 2. So we check what the eigenvector is, or eigenvectors in this case. We could get 2. So we define V to be have components CD, which we're going to determine. We look at A minus -2i, so A plus 2i, B. And we want to find V to equal 0, or that makes this expression equal 0. This is going to be -2 plus 2, 0, 0, and -2 plus 2 times CD equaling 0, 0. This goes to 0, 0, 0, 0 times CD equaling 0, 0. This gives us no real information, no constraints on C and D, because the two equations just simplify to 0 equals 0 and 0 equals 0. So that means C can equal anything. So C equals C and D equals D. So that means our vector V is going to equal CD, or C C0 plus 0D. And we can choose C and D to be whatever we want. So we get two vectors, 1, 0, and 0, 1, if we choose C to equal 1, D to equal 1. So our two eigenvectors are then 1, 0, and 0, 1, which is what we said in the concept video would happen in this case. So that means our fundamental solutions are e to the -2t v1, which is 1, 0, and e to the -2t v2, which is 0, 1. So our solution then is y of t equals c1 e to the -2, 1, 0, plus c2 e to the -2t, 0, 1. But we have an initial condition, which we can use to solve for c1 and c2. So first I'm going to simplify this a bit. I'm going to write this as c1 e to the -2t 0 plus 0 c2 e to the -2t. Or in other words, c1 e to the -2t and c2 e to the -2t. So this is y of t. If we plug in our initial condition y of 0, we get c1, c2, because these will just become 1. And we know this equals 3, 2, or 3, -2 by the problem introduction, so that means c1 equals 3, c2 equals -2. So our particular solution is then 3 e to the -2t, -2 e to the -2t. For our third example, we have the system y prime equals ay for a equals 3, 1, -1, 1. So if we look at the determinant of a minus lambda I, which is going to equal lambda squared minus the trace of a lambda plus the determinant of a. The trace is going to be -4, and our determinant is actually going to be +4. So this factors to lambda minus 2 squared. And setting this equal to 0, this gives us one real eigenvalue of 2. So we can look for what v is for a minus lambda I times v equals 0. and this will be v1. It's going to be a minus 2I times v1 equaling 0. We define v1 to be ab. This gives us 3 minus 2, 1, negative 1, and 1 minus 2 times ab equals 0, 0. Writing this as an augmented matrix, we get 1, negative 1, 1, negative 1, 0, 0. If we subtract r2 by r1, get 1, negative 1, 0, 0, 0, 0. So this tells us that a minus b equals 0, or a equals b and b equals b, which tells us ab equals 1, 1 times b. If we set b equal to 1, then we get that b1 equals 1, 1. So we have our eigenvalue in algebraic multiplicity 2, but geometric multiplicity 1. So we need to find one more eigenvector, or one more vector to use in our solution set. So y1 is going to be e to the 2t v1, but we're going to have a y2, which equals e to the 2t times v2 plus t v1. So v2 is going to satisfy the relation a minus 2I v2 equals v1. So we know v1 is 1, 1. And if we say v2 has components cd, we can write this as cd. And we know this matrix a minus 2I is 1, negative 1, 1, negative 1. So we can write this as an augmented matrix, 1, negative 1, 1, negative 1, and then 1, 1. If we subtract r2 by r1, then we get 1, negative 1, 1 on top, and 0, 0, 0 on the bottom. So this tells us that c minus d equals 1, or c equals d plus 1, and d equals d, or v2, which equals cd, equals d plus 1 and d. Since we can choose d to be anything, the simplest case would be if d was 0. So that gives us, and this is v2, v2 equaling 1, 0. So since v2 equals 1, 0, our second solution y2 equals e to the 2t times 1, 0 plus t 1, 1. So we can simplify this to be e to the 2t times 1 plus t over t. So our total solution is c1 e to the 2t 1, 1 plus c2 e to the 2t 1 plus t and t.